Welcome to our new unit, CP3. In our first lesson here, CP3-1, we're going to talk all about the vocabulary of this unit. So by the end of this lesson, you'll be able to identify and use circumcenters, incenters, and orthocenters. The first vocabulary word you need to know is concurrent, and it means that they intersect at the same point. So these lines are concurrent because they intersect at that same point. Here are some special segments you should already know. So the first one is altitude. Remember, the altitude creates that 90-degree angle with the other side. The median splits the other side in half. The angle bisector splits the angle in half. Finally, we have a perpendicular bisector. This one is kind of like if you had an altitude plus a median. What it does is it creates that right angle, but then it also cuts the opposite side in half. Notice this perpendicular bisector, though, is different. It doesn't necessarily go through that opposite vertex like the altitude and median always do. Let's take a look now what happens if you construct three angle bisectors, and I'm going to do my best to draw this. It's not going to be perfect technically. What we would actually need to use is a protractor to get it to be exactly correct. So I'm going to cut my angle in half here, up here, and here. Again, I know that's not quite perfect. They should all be straight lines. And notice what happens is they all come together at that one point. Since they're all coming together at one point, we learn that those lines then are concurrent. So three angle bisectors of a triangle are concurrent. And they meet at a point called the incenter. Remember, these were angle bisectors, so each of these lines cut their angles in half. With the incenter, we do have some special properties. We just looked at that they're formed from angle bisectors, and they're going to be equidistant, so the incenter is going to be equidistant from the sides of the triangle. So if I were to draw a triangle here, and we look at our angle bisectors, again, bear with me, that wasn't perfectly drawn, but those are angle bisectors, and they meet at the incenter. What's going to actually happen is we're going to get a circle here, okay? And yes, that circle is not quite perfect because I'm freehanding this. But what happens is that point is going to be equidistant from each of the sides. That radius, right, in a circle has to all be the same. So again, since the radius has to be all the same, the incenter ends up being exactly the same distance from each side. The incenter is the center of a circle that is inside the triangle. It is equidistant to the sides because all the radii of the circle are equal. That's what we were just looking at. We're going to use the incenter when we want to place an object the same distance from three paths. So roads, rivers, highways, hallways, whatever it might be, just as long as those are lines. Okay, so this is big. It helps us to remember when we want to use the incenter. Now let's look at what happens if you construct three perpendicular bisectors. So let's remember the perpendicular bisectors cut the line in half. So here and here cuts it in half. And then it's going to make a right angle. We're going to do that on all the sides. So here and here. And remember, this is not going to be perfect as I am drawing freehand. And then finally, the last one. Notice these perpendicular bisectors are also meeting at a point. So the three perpendicular bisectors of a triangle are concurrent. They meet at a point called the circumcenter. With perpendicular bisectors in our circumcenter, what actually happens for our circle is that we go through the vertices, and that circumcenter is equidistant from the vertices because those radii are all the same. So circumcenter is formed from perpendicular bisectors and it's equidistant from the vertices of the triangle. So the circumcenter is the center of a circle that goes around the triangle. It's equidistant to the vertices because the radii of the circle are congruent. We're going to use the circumcenter when we want to place an object on the same distance from three towns, cities, trees, buildings, fountains, intersections, etc. So for example, let's say sometimes this happens in smaller places. So let's say there were three cities here, here, and here, and they weren't big enough to have a high school of their own. What they actually do is they want to figure out, okay, where's a good spot for the high school to be for each in relation to each city. And so what they're going to do is they're actually going to find the circumcenter to figure out where that would be. And they would use the circumcenter to make sure that they're the same distance from each of these towns. Now, sometimes this doesn't happen. Like, let's say these towns were nearly in a row. Not there. Let's try like here. If it was here, just a little bit off, and here. If I were to actually draw that circle and find the incenter, okay, it would actually be far away from all of the towns. So that's why I say sometimes they use this. Let's now take a look at what happens if we construct our three altitudes. Remember, the altitudes are perpendicular to the opposite side. So we have that one, we have this one, and we have our last one. Notice they come together at a point. So the three, this should say altitudes of a triangle are concurrent. And they meet at a point called the orthocenter. The orthocenter is found or formed from altitudes. And in this one, there's no special properties like the other two. All right, let's summarize what we learned here today. The circumcenter is formed by perpendicular bisectors. Looks something like that. And it's equidistant to the vertices. So remember, this is where our circle is outside, and that point is equidistant. The incenter is formed from angle bisectors. Looks similar to that. Remember, this is the one where the circle is on the inside, and it's equidistant to the sides. Finally, we have the orthocenter, and that's created from altitudes. There's a picture of it, and really there's nothing much special about it. One more thing you need to know. When you hear where it says circumscribed circle, that means the circle's on the outside. Inscribed triangle, that means the triangle is inside. An inscribed circle means the circle's on the inside. A circumscribed triangle means the triangle is on the outside.